So at this point, this series has probably been pretty boring, even as a CS presentation. We've mostly just covered low-level aspects of these different languages and how they compare. But in this part, I'd like to go into some of the more exciting and unique features that really make Elixir stand out from the rest. But before we really get into the nitty-gritty of Elixir, I did want to bring up what I consider one of the most overlooked aspects of Elixir, and that is the track record and maturity of Erlang, which is ultimately the language that Elixir is based on. As I've already mentioned, Erlang was invented in 1986 with the intent of supporting massive fault-tolerant concurrency in telecom. And although it was designed for this very specific use case back then, as the web and APIs have become so prevalent in today's world, Erlang has made a comeback with the help of Elixir, which has added a modern flavor to the language. And although I won't really go into how Erlang and Elixir relate and where one begins and one ends, I would like to highlight the community and ecosystem around Erlang that has made it so successful. In addition to the Erlang language and VM, known as Beam, there's this ecosystem of tools and best practices that have sort of emerged over the years when using Erlang. This is more commonly known as OTP, or the Open Telecom Platform. OTP can be a little difficult to describe because it's not necessarily just a list of packages or technologies, but really makes up the Erlang ecosystem as a whole. Some of the things you'll find in OTP are some use case specific databases, some testing tools, some debugging tools, static analysis tools, as well as something known as Observer, which is a pretty cool desktop GUI that allows you to really dive into a running Erlang application and analyze it in a variety of different ways. This is just a screenshot, but the desktop app allows you to really drill into system metrics such as CPU and memory, where that memory is allocated, the various processes that are being run, and even some tools for some dynamic tracing. And what you'll see here is a list of actual running applications. As we talked about in the concurrency section, one of the things that separates Elixir from the pack is its application abstraction, which is sort of a top-level way of organizing these green threads. And in Observer, you can actually visualize and drill into these various processes that are running. So this is something that I haven't seen in other languages that really can be useful when trying to diagnose specific issues or see if memory leaks are occurring, or a variety of different use cases where Observer can be relevant. But it just kind of goes to show some of the benefits of OTP and the fact that Erlang has been around for, what is it now, 35 years, which really beats any of the modern competitors that we've been looking at. Most of them have been around for 10 years or less. So although Elixir itself is about the same age, it is built on technology that is going on 40 years old. Another unique feature of Elixir and Erlang is its approach to error handling. And as we've already discussed, processes in Erlang can be supervised, which means that processes can be automatically restarted should there be a transient error or some other issue during execution, while also introducing a different approach to error handling in general, where most languages prefer to be highly defensive in their error handling, meaning that you're always trying to catch any specific error that may occur and handle that error gracefully. Elixir can be more forgiving while also providing the same mechanisms that you'd be used to in other languages. So you kind of get the best of both worlds here, which tends to be a common theme in Elixir, where you can do what you're used to, but it also sort of adds an extra layer of sophistication that you can rely on or use if appropriate. So really, you can treat your application as you normally would and write your, handle errors accordingly. But should you miss something, or maybe you need to prototype something rapidly and don't want to account for all these different errors and just need to get something out quickly, you can rely on these supervisors as a fallback until you're ready to make your code more robust with proper in-depth error handling. And at the very least, challenges how we think about errors in our applications in general. We've already briefly touched on the ability to swap out code in real time on production systems with Erlang. And although this is probably not something you'd use on a regular basis, especially given the way that we deploy applications today, it can be helpful as a debugging tool and way to test out changes on a production system before deploying. Rather than redeploying your application, which sometimes can take 5-10 minutes depending on your build tool, you can instead remote into the live running server, update code in real time, test that out, and iterate until you resolve the issue. At which point, then you can make changes in your code base, commit to your repo, and deploy as you normally would. Sometimes it might take 5 or 10 code changes to fix a production bug as we experiment. And if we go through the regular pipeline, that could mean an hour or two. Whereas with hot code swapping, that might take 10 to 20 minutes to try all those different permutations instead until we come up with the right solution. So hot code swapping can be useful for debugging, especially production systems, but probably wouldn't be how you normally deploy your applications. As already mentioned in the paradigm section of this series, Erlang's functional paradigm lends itself nicely to distributing load across multiple nodes in a cluster. Nodes in an Erlang cluster can use the distributed Erlang protocol, which simplifies communication and message passing across these various nodes and makes it easy to create Erlang clusters right out of the box. Nodes can even auto-discover each other. Although not unique to Elixir, I do think it's worth mentioning that Elixir does support macros. For those unfamiliar with what macros are, they are essentially a way to write code that writes code, if that makes sense. It's considered metaprogramming, meaning sort of a layer even above your code. And it helps with a variety of different things that may be more tedious or challenging to do otherwise. Now, Rust also supports macros, while Go and Node do not. In the case of Go, I think it's an appropriate design decision due to its goal to keep the language simple and straightforward and familiar. Macros are powerful features, but can also be misused, and in the case of Go, probably not necessary. However, in the case of Node and JavaScript, in my personal opinion, not introducing macros early on is perhaps the biggest problem JavaScript has. Now, I don't know the implications of introducing macros to JavaScript and web browsers, and maybe there's a good sound technical reason why it hasn't been introduced, but I will say the consequence of not having a proper metaprogramming mechanism is the plethora of tools that are needed to write modern, compliant, backwards compatible JavaScript code. Rather than using macros to support new ECMAScript capabilities in old legacy browsers, the JavaScript community has instead relied on transpilation, most notably Babel, to accomplish this. Transpilation is a way to transform written code into a compliant code that would run on most browsers and sort of introduces somewhat of a compile step, although it's not technically compilation, it's transpilation. It does add somewhat of a compilation step to the modern JavaScript workflow, which in a lot of ways eliminates the benefit of an interpreted language. In addition, it creates a variety of inconsistencies across projects, and anyone that's had to maintain Babel ecosystems with all the various plugins and then its integrations with Webpack or other language management tools. Anyone that's had to do that will realize the amount of complexity that it introduces to a project and how fragile and brittle these ecosystems can be, especially when it comes to upgrading the versions. With macros, there would be a single mechanism baked into the JavaScript engine itself that could support macros and therefore extend the language in any way that is desired without having to introduce this additional step of transforming code. So again, I don't know if that was ever a realistic possibility, and perhaps maybe just a limitation of the JavaScript browser environment. But in my experience, transpilation has really caused a lot of challenges and maintenance overhead that I think macros could have solved from a very early stage and really would have made writing browser compliant code far simpler without the need of all these extra tools. So Elixir and Rust support macros. Go does not, but is probably appropriate that it does not. And Node, in my opinion, desperately needs some form of meta programming, although at this point is probably too late. Mix is a command line tool that is used to manage your Elixir projects. That includes everything from installing dependencies, compiling the project, to custom mix tasks that may be included in various packages that you load into your project. Perhaps some of the most popular mix tasks that aren't included out of the box are part of the Phoenix framework, which is an extremely popular framework for web and API development. Here's an example of various mix tasks that are included in Phoenix, which can do anything from print out all your API and web routes, which is immensely useful, to starting the application, to managing your static files, things such as images and JavaScript files, and also includes a variety of code generators, whether that's creating a database model, generating secrets, or creating MVC files, your model view and controller for any type of web resource. Code generation in general is a fairly common practice in Elixir, and something I haven't found as commonly used in other languages, and I found can be extremely useful for creating admin dashboards for your domain. For each Phoenix model that you introduce, you'll get a variety of HTML pages and models that will enable you to create, read, update, and delete the various entities that are used in your application. Outside of Phoenix, there's another common code generator mix task that I like to use, which handles all of the authentication for your application. Anyone that's had to implement authentication features by hand knows how tedious and repetitive this work can be. You know, creating login screens, registration screens, reset your password, confirmation emails, all of that can take a lot of time while also being critical to get right especially in order to create a secure application. And so the actual creator of Elixir, Jose Valim, based on really a handful of different attempts, ultimately decided that libraries and frameworks for authentication aren't really the best way to go, and instead a code generation approach is most ideal, where you can be provided really all the common bones of an authentication system, but then can customize the code as you would any other code in your project. So this really gets you up and running really quickly with an application that needs authentication, while also providing the ability to customize it to your needs fairly easily. So these are just a couple of examples of how mix and custom mix tasks can help improve productivity and ultimately make your job easier as a developer. I've also found the Elixir language itself has a variety of really nice features that are both extremely useful and also a pleasure to work with. Now, I'm not going to go into everything I like about the Elixir language here, of course, but I have handpicked a few examples that I think will demonstrate how pleasant the language can be to work with. Now, the first of these is the support for recursion as well as pattern matching and guards. You'll see in this example here that we've actually defined this same function 2 times. In this first definition, we have n as the second argument, and then the second we have 0. So what's going to happen is, with pattern matching, this second will run whenever this second argument is explicitly 0. Otherwise, it's going to run this top function. But additionally, we have a guard on this function, which says that this will only run when n is greater than 0. So essentially what we've done here is we've defined the same function, but with different instructions based on the arguments that were provided. Now this works really well with recursion, as we'll see here. Basically, we want to print hello 3 times based on these arguments. So what will happen is we'll provide hello as the message. We'll see that n is in fact greater than 0 because it's 3. And so we will print to the console this message hello, so we see right here. And then it's actually going to call itself again, but this time with n minus 1. So now n will actually be 2, which means that this is going to execute again, but with n now is 2. And then it'll subtract again, and then n will be 1, and then finally it will run once more, and at that point n will be 0, so it no longer matches this pattern, and will instead execute this definition, which will instead return OK. So this is a good demonstration of how recursion along with pattern matching and guards can all be used to write code in a recursive manner without having large conditionals within a single function declaration like you would normally see, where you have if statements or if else statements. So sort of a different way of approaching writing code, but in my experience is much cleaner and helps keep your code organized. Perhaps my favorite part of using Elixir is the pipe operator, where you are basically creating a pipeline of different operations on a specific piece of data. And this can be done and is done in a lot of other languages, but in my opinion, Elixir really does a good job at making this really straightforward and easy, whereas in some other languages you might have to create constructs to accomplish this form of function chaining. So as an example here, we'll see that we start with the number 1, and we have these add and subtract functions below. And basically what the pipeline operator does is when we see this pipeline, basically the previous value is going to be passed as the first argument here. So we'll see 1 is basically added to the first argument, so we will get 1 plus 3, which would be 4. And now 4 gets piped into the first argument to this add, so now we're at 14. And then we subtract from 14 5, which gives us 9, and then finally we add 2 more, which gives us 11. Another more practical example would probably be in a real system is like a place order type of procedure, where we take in a customer and item, we start with the customer, we pipe that into order, so really the first argument to order is customer, then the second is item, and then the result of that gets piped into allocate inventory, generate invoice, update billing, notify customer. It really sort of makes it very, very readable, the different operations and procedures that we have, and is really quite useful for things like business rules, change sets in Ecto, and really is used throughout Elixir as a standard practice. We also have the concept of atoms, which I haven't seen in too many other languages, and is really useful in pattern matching because it's sort of like a constant that refers to itself. So you don't even really have to just define a value for a constant. It's just, it is itself. It's kind of hard to explain. And admittedly, there's some times where they kind of frustrate me, especially with maps, because the keys of maps in Elixir can sometimes be strings and sometimes be atoms, and sometimes that can be kind of annoying and cause problems. Atoms can be quite useful when returning results from an operation that may or may not succeed. And a lot of times you'll see operations that return either OK or error, or perhaps in the case of HTTP status codes, you will see the various status codes expressed as atoms. And finally, there's with do else, which I found to be very much a useful way to handle chained operations that may or may not succeed, which tends to be pretty common, especially when you're working with databases or APIs or anything that may or may not give you the result that you're expecting. So what with do else will do is use pattern matching to determine whether to proceed to the next step. Basically, everything in your with clause will be your happy path. Basically, everything that you expect to happen, assuming everything goes right. But your else clause will handle any patterns that don't match your happy path, which is typically if you get an error response or something that just doesn't match what you're expecting. And then you can handle that accordingly. So what you end up with is a nice clear separation between your happy path and anything that could potentially go wrong, which makes it quite easy to handle errors in a consistent manner, as well as define complex chains of operations that may or may not succeed. So again, these are just a few examples of language features of Elixir that I found useful and I use regularly. And ultimately are a few things that I'd like to see done in other languages, especially JavaScript, where you're doing a lot of similar types of operations. As someone that's built many single-page apps using technology such as React, I find Phoenix LiveView to be quite exciting. And that's not only because it gives me the ability to really ditch JavaScript altogether for writing front-end applications, but it is also a pretty unique way of building responsive applications. With JavaScript-based UIs, you typically have to package together your application in a fairly large JavaScript bundle that needs to be downloaded by the client prior to any execution. This can cause problems for search engines and initial time to paint for your application, though that can be solved by server-side rendering. However, server-side rendering introduces its own complexity and typically requires changing how you would normally build that application. Phoenix LiveView, however, is almost like creating React components, but on the server. And what will happen is the user events and computations will take place on the server instead and push changes via WebSocket to the client UI in the web browser. And although this might not be the right approach for some use cases, it can have some advantages as well, especially for applications that may require server-side rendering or quick first paint, or for organizations that really want to stick with Elixir across the stack, including the front end. This can also be used to offload a fair amount of functionality from the client to the server, which may or may not be appropriate for your use case, but can help clients, especially those that have limited processing power on their device, but may require your servers to instead handle that load, which may or may not be desirable. Regardless, whether practical for your use case or not, it is a very exciting and interesting technology that I find very fun to work with and is at the very least worth trying out. And depending on your business or project goals, could be a much better alternative to the existing JavaScript application frameworks that exist today.